right now. So hi, it's lab 4. Wanted to just remind everybody that next week is your 5th lab, and then you're done with biostats. I got rid of basically this lab and next lab are encapsulating what I would have called a final project in some ways. So this lab's a little bit longer than previous ones, and it's worth 20 points instead of 10 points. But doing lab 4 and 5 basically means you're done for the semester, no big project on its own, no final exam, nothing like that. So these are your last 2 kind of things to get through, and then you're done. If you haven't heard yet, we're still having course evaluations for this year, but obviously they won't be on paper, and so you're going to get an email. Has anyone gotten the email yet about course evaluations?
Yeah.
Oh, you have?
Yep.
Okay, so it went out this week. That's good. I don't feel the need to necessarily have you guys do it during class time, because I'd rather answer stats questions during that time, but please fill it out if you can. It's good feedback for the school about online classes. It's good feedback for me. This is a bizarro semester, so it's hard to exactly know, if you have a lot of criticisms about taking a class online, yeah, we get that. None of us wanted to do it that way. So I don't really know how we use that type of information, but anything you want to give is great. So please make sure you do that. I always say it's important for people like me who don't have tenure yet to kind of have these evaluations on the record. So that's my little pitch. Today, I wanted to give you some notes because I graded lab 2 and I'm working my way through lab 3. Make sure you understand what I mean when I say write a statistical summary. I laid it out really clearly early on, but these are more and more important. Basically, these are these 2-sentence summaries that would go in your results section, or you'd give to a collaborator or your professor that kind of say the results of your statistical test. And I kind of have a very prescribed way that I want you to write them, and I give you that format each time. So some of you guys are getting it perfectly, and it's one of these things that you don't have to be creative about. You're just going to write it exactly the way that I tell you and put new numbers in it. If that isn't making sense to you, shoot me a question about it. You don't have to worry. You don't have to include super long decimal points in those statistical summaries. Think about it was really obvious on your data that was on salary, because you guys had 5 decimal points, but salaries in dollars. So at best you should have 2 decimal points there. So just try to be thinking about that as you're writing it. What am I actually trying to accomplish here? My reader doesn't need to know a million decimal points. And then your graphs are going to start getting really long code. Today you're probably going to do your longest code on the graph. So I want to make sure that you guys realize really how you should be doing it is using multiple lines in RStudio. So when you have your script the way I have it here, right, I can kind of see this is my setting up coordinates line, this is my point line. You're going to learn these guys today. And then as long as I have a plus sign at the end of each, they all kind of add on to the next one, but that you can see what's on every line. That's really important, instead of having everything on one line going on like that. Okay, any questions about that stuff? I want to go over linear regression super fast just to make sure you guys are all remembering this, since that's what's the lab on today. Any other questions before I jump into this?
I have a quick question about finals week. So we don't have to come to we don't have anything to hand in for finals week, so to speak. Just the lab 5 is going to be the last thing.
Yeah, and technically because finals start next Wednesday, right?
Mm-hmm.
So technically because it's due Friday, you're using some of finals week in my mind to do that lab 5, so that's why I'm counting it all good. But no, the week after, nothing is due for this class unless you are behind on your labs and need to get them in.
Okay.
So no, these are your last 2 things. Okay, so linear regression, just a quick refresh on this stuff. We remember that linear regression is finding a line through the data that best predicts y from x. It's trying to minimize that sum of squares distance. So the goal is to fit a line through the data that minimizes the sum of squares of the vertical distance to the line. This sum of squares is the same sum of squares that we talked about when we were talking about ANOVA, which is why when you do this analysis this week, you're going to get an S statistic and a p-value associated with your linear regressions. So remember, you need to report a whole heck of a lot when you're doing a linear regression. You need to report that S statistic and that p-value. You need to report the actual equation of the line that you found, because that's important, what that line fit through. And remember that that's in the format y equals mx plus b, where m is your slope and b is your intercept. And then finally, making sure you choose x and y is really important. So I'm going to kind of make you guys do that. But remember, x is your independent variable, what you can vary in the experiment, and y is your dependent variable. This responds to whatever is varied in the experiment. The variable under experimental control is always x. In ecology, we often don't have a ton under experimental control. And in those cases, you choose which one is your x and which one is your y. I think in all of the examples today, no, in 2 of the 3 examples today, the X is experimentally controlled. So that helps you understand when you read about the data set, which one should be X and which one should be Y. So you're going to get a p-value for your linear regression. Remember, the null here is that there's no difference from a horizontal line. So there's no relationship between the variables. The alternative is that there is a difference from the horizontal line, or there is a relationship between the variables. The p-value is if there was no relationship between the variables, what is the chance that we would observe a difference from horizontal this strong, right? And then remember, linear regression and correlation both use R and R squared. So R is the correlation coefficient that shows the direction and the scatter around the XY relationship. So that was one that the sign of it shows if it's a positive or negative relationship, and how close to 1 it is shows how good that relationship is. We're going to use more often in linear regression this R squared, the coefficient of determination, which shows the fraction of variance in Y that is predicted by changes in X. So when you're doing your statistical summary for regression, you need to include not just the F and the p-value, but this R squared value, because this really is kind of giving you more information about how good of a relationship these 2 variables have. So make sure you're reporting that R squared value. And I kind of walk you through, there's a big output that comes from linear regression in R, and I show you in the Google Doc which one we're supposed to be reporting. Oh my God. So just going back to the assumptions of linear regression, the model is correct. The scatter around the line is Gaussian. Variability is the same everywhere. Everything's independent, and you know your X values. So remembering that is important. The mistakes, concluding there's no relationship between X and Y when R squared is low. That's why you report both. You report both a p-value and your R squared, because sometimes you can have a significant p-value and a really low R squared, which means this isn't an interesting result. And so you really need to think about which is X and which is Y. You need to always be graphing to see making sure what you see in your data matches the results of your linear regression. And you don't want to extrapolate beyond the data, and you don't want to overinterpret a small p-value. So again, if your p-value is really small and you're going to reject your null hypothesis, but your R squared value is super low, that could mean that this is not a very interesting biological result. So today I have lots of new code to talk to you about. I want to just step you through this really quickly, showing you my screen. So you're going to get to this in your 3rd part today, but I want to show you what you're working with. So hopefully this is all starting to make more sense, right? So when I tell you to load data from case 0901, you're going to load it like this, right? So now we can see metafoam is over here, 24 observations of 3 variables. This here is going to make me a graph. Hopefully that makes sense. And this is new code for today. This geom smooth is creating this regression line through our data. Other new code for today is this called facet wrap, which is basically going to make multiple graphs based on some sort of categorical variable. So if I run this, instead of this graph that's 1, it should split it into 2 different graphs. And now I have these kind of faceted 1 and 2 here. And so that really helps you be able to visualize things a little bit better. You're also going to learn how to do this if-else statement. So if-else is really handy when you need to rename your data something. So what you're going to do here is say, I want to rename this column that's called time, something that's called early and late. So the if-else statement says, look into this, this column that's time. If it equals 1, I want you to say, I want you to return early. If it equals anything else, I want you to return late. So what this does, when you run this, you're going to see now there's a fourth variable in our meadow foam, which is timing group. That's what we just made. And when we look at the top of this, now any place that there was a 1, you now have early coming in. Hopefully this makes sense as you go. You're also going to learn the code for regression, which is right here. It's another one of those 2-step functions where you need to have them both together. And then you're also going to learn how to subset your data. So now instead of just working with one object, we can actually use this subset function, and it's going to break our data apart into early and late groups. So when I run early, now I have a new object up here that's just 12 observations, half of the observations of 4 variables. If I run the second part, which is late, I'm going to get a new object called late. And then you can run regressions on that subsetted data. In the end, I want you to make a really pretty graph. So this is all the graphing code that I have, and I want you to modify it to make it look nice. In the end, you can make something that looks as nice, hopefully nicer than that, with nicer colors and shapes and things. So that's kind of where you're going today. I think it should hopefully be pieced out step by step just fine. But I'll be here to answer your questions. Anyone got any other questions for me? Okay, cool. I'll be here. I'm gonna stop recording.